Now we're ready to finish our section on conic sections by looking at translating. And we've actually already done that with circles and parabolas and talked about it with ellipses and haven't done it with hyperbolas yet. However, we're going to have a generalization of all the formulas here. And a good thing to do would be to turn off the video and you to jot down from memory what you think all the formulas are, and then you could double check and make sure that you were okay. So if you turn it off now, and then you can turn it back on, and then I will slide this down. Okay, so let's review. So for parabolas, if we have parabolas that are with a vertex at 0, 0, we know that these are our two standard formulas. This one is going to either open up or down. With the x coefficient, it will open left or right. And we know that there's also a directrix and a focus. And here is our generalization if we have the vertex move to a different location. So we've used those quite a bit. So those are pretty standard, and we actually worked with the standard form from the very beginning, putting things in vertex form and completing the squares and so on. So for circles, we started with the standard form right away as well. And remember the key thing, both variables are squared, but they have the same coefficient on the x squareds. And remember, we have to complete the square sometimes, two different times with the x variable and the y variable to get it in that form. For ellipses, we started out in section 4 dealing with having them centered at 0, 0, and then we had at least one problem on homework where we did have it moved from the center of 0, 0. However, here's our generalization. So starting with being centered at 0, 0, we know that in each case when we write it in standard form, we want to lead with the x coefficient. However, the a squared is always the larger of the two between a and b, and we will have that condition that it can move depending on where it's elongated. So if the larger number is underneath the x, then we're going to have it elongated in the x direction. If the larger number is underneath the y, we're going to have it elongated in the y direction. We do have two fixed points, the foci, and remember that really this little diagonal that's here, we have the b value and then the c value. There's a little right angle there, and that diagonal right there is actually the length of a, which is from here to here, and that's where our Pythagorean theorem comes from for that relationship. And then if we slide them left, right, up, down, we know that these are the formulas that we'll end up having as our standard form. But we always want to lead with the x's. Then for hyperbolas, we've centered them at 0, 0 before. And we know that the a term does not necessarily have to be bigger than b term by any means, but whatever the square root of whatever coefficient is underneath that variable is how you're going to move in that direction to start to make your box. So the a squared's underneath the x term, the b squared's underneath the y term. In the x direction, I'd move a left and right. And in the y direction, I'm going to move b up and down, make my box, make my diagonals. And remember, we have equations of asymptotes that we can find as well. And then our vertices are going to correspond with that lead variable. They're going to be in that x direction, going to open left and right. And then our hyperbola that opens up and down, same idea. In the y direction, we're going to move a units up and down to get the endpoints of our box. These will also be our vertices in this case. And in the x direction, we're going to be moving b units to the left and b units to the right. Get our box, get our asymptotes in there, and remember that's the relationship between a, b, and c. If here is a, and this is b, this is also a, and remember this diagonal right here is actually how long c is. We almost took a little compass and put the little tip here and put the pencil lead there. We could actually arc up and find the location graphically. And as you might expect, if we're going to shift these so that the center is no longer at 0, 0, we have our hyperbola forms for our standard form, our generalizations. Okay, now we're ready just to go through and do a little bit of practice. And basically, if we sketch graphs of situations, we can figure things out quite nicely, even without going through the formulas, just kind of using the idea of what happens with parabolas and what happens with circles. We can kind of figure out what happens with these other translated versions as well of the ellipses and the hyperbolas. Okay, so let's flip and start. So we want to write the equation of an ellipse. So we know we're going to have an ellipse. We could actually write down the part of the formula right now with a center at negative 2, 4. I'm going to stop. I actually know quite a bit of the formula right now. X plus 2 quantity squared over something, and then plus, this is a subtraction sign if it's a hyperbola, but for an ellipse it's a plus, and y minus k quantity squared. Now, I don't know what's a and I don't know what's b. I don't know if this is a squared and this is b squared or vice versa. So I keep reading. I have a vertical up and down major axis. Major axis is vertical, so I know it's long this way. And I have it centered at, whoops, and I forgot to put that 4 down, didn't I? You saw that. I caught myself. So we know we have a center at negative 2, 4. So here's 1, 2, 1, 2, 3, 4. There's where our center is. And I'm just going to call it CR so it doesn't look like it's the C value for the focus. And we know we have a vertical major axis that is length 10. So we know we actually move up 5 units and down 5 units to get to the vertex of this. So there would be a vertex up here and a vertex down there. So I know that A is 5. And I have a minor axis that's 4. So I know I would actually move 4 units to the left and 4 units to the right, which I did kind of in reverse order, but this is 4. Not too far from circular, but there would be my ellipse, and it's elongated this way. And so I know that my little b value is 4. And so in the x direction, I'm moving 4, 4 squared, got the 16. And in the y direction, I'm moving up 5 units, 5 squared, 25, and I'm done. It doesn't ask me to find the focus, where the location of each of the foci is, or where the focus is up here, focus is down there. If I were going to find the focus, I would remember that the a is the longest in the ellipse, and that a squared equals b squared plus c squared. So I could pop these numbers in here pretty easily and figure out where the foci are. Okay, number 2. Now we want to write the equation of a hyperbola. So in my mind, I'm thinking, yet I don't know whether it's going up, down, or left, right. And it gives me vertices. I got to graph this. I can't visualize. I can't even start to write the standard form because I don't know whether to put the x term first or the x term second. I need to know which way it's oriented. So quick little sketch here. I know I have a vertex at negative 1, 2. So negative 1, 2. I know that's a vertice. And I have one at 3, 2. That's a vertice. Tells me a lot. I'm going to stop there. I'm not even going to read the foci information yet. I know that this hyperbola has to open up this way and open this way. So I automatically know I'm going to need to have that x minus h and the y minus k equals 1. And I'm ready to figure out where the center is. I know the center has to be halfway between here. And I can eyeball it truthfully on my graph, and I can see that the center is going to be located here. If this point is negative 1, 2, and this point is 3, 2, a couple different things. I know the y-coordinate of the center is definitely 2. And I can either count spaces to go in or find the mean, the average of these two x-coordinates. So if I add them together, 2 divided by 2, I'd get 1. And I can also see that from just my picture of my graph. So there is my center. I'm ready to plop that in. Now I can see the only other piece of information I need is I need to figure out what a squared is, and I need to figure out what b squared is. And I actually can see a. A is right there. That distance from the center to a vertex is my A, and I can see A is 2. And I know that goes in the x direction, so A squared is 4. And now I need to calculate what this B is, which means I'm going to have to keep reading. I'm being told where my foci are. And I have my one focal point is at negative 3, 2. 1, 2, 3, up here at 2. And that tells me a lot, because the distance from the center to the vertex is little a, but the distance from the center to a focal point is little c. And I can actually count my squares, 1, 2, 3, 4, and I can see that c is 4 units long. And likewise, if I go the opposite direction, I'm given 2 foci. I really only needed the 1. And if I go over to 3, 4, 5, and 2, and there's where the other focal point is. And if I count my squares again, 1, 2, 3, 4. So I can see that there's a distance of 4 units this way. So C is 4. And I remember that C is the longest measure in the hyperbola. So C squared equals A squared plus B squared. Therefore, 16 has to equal A squared plus B squared. And so I know B squared has to equal 12. Now, I was not asked in the directions to actually graph this, although you can see I definitely did quite a bit of the graph. And I know that B is actually the square root of 12. And I would probably get a decimal approximation if I were going to graph this accurately, so I'd know how far to go up to make that box. But in reality, I just need B squared, and I have my equation. Make sure you put B squared there and not the B value. Okay, so far so good. This question you might want to even just breeze through and do on your own and then double check the answer, because it looks like it's going to kind of be repetitive of this one. It's another hyperbola where you're having the vertices and the foci. So you could either fast forward if you understood that concept, or turn it off and do it on your own and then come back. So I'm just going to continue on. And this time I have my vertices. I know it's a hyperbola again. Got vertices at 2, negative 1, so there's one vertex. And I have another one at 2 and 7. Okay, and once again, I am going to stop, and I'm going to write down quite a bit of this. I can see that the hyperbola is going to open up this way. So I know in my general form, I'm going to have y minus the center squared minus x minus some other center point equals 1, and I'm going to have to figure out little a and little b, but I'm going to know a whole bunch of this real quickly. I need to figure out the center. The center point has a x-coordinate of 2, and instead of counting squares, I'm going to find the mean between these two y-coordinates, and add them together. I get 6 divided by 2 is 3, so 1, 2, 3. There's my center at 2 and 3. I could also count squares. And now I'm ready to plop these into this. Make sure you put the y with the y. Now I also know that the distance from center to the vertex is little a, and I can see that that distance is 4. So I actually know a squared is 16. Got one thing to find. Going to have to look where the foci are located to figure that out. 210 is one focal point. This was at 27, so I'll go up 3 more. Now be careful if this is one focus point, which I'm not even going to worry about graphing the other one because I'm going to be able to figure out what C is from this. Make sure you don't use this distance as C. Remember, the distance is from the center to the focus, and I can see that I moved up 7 units. So C is 7. So now I'm ready to use that relationship. We know that C squared is equal to A squared plus B squared. And we know that this is 49. And we know the A squared was 16. And I got to find my B squared. And so do that subtraction. That looks like that's 33 to me. And once again, I'm not asked to graph it. The square rooting this, I can find B, so I can figure out how far to move left and right to get my appropriate box. But to write my equation, I am good to go. and then the last thing we'll do is we're going to look at, on the back side, is doing a little bit of work with completing the squares. These two questions are very similar. And so we're going to, on the first one, we have to identify the conic section, and then we have to give some information about it. So first of all, I look at this and I see, both variables are square, it's not a parabola, and the x term is positive, the y term is negative, and I can see that that's going to cause me to have a hyperbola. Now, I know I have to find its center and the foci, and so I'm going to definitely want to put this into standard form. So I'm going to put my x's together, and then my y's together, and I only have one y term. And remember, be a little bit paranoid. Go back and double check and make sure you didn't make a mistake in writing it down, so it looks like I'm okay. Now I'm going to have to complete the square in this part. The y is all done. There aren't any other y terms, so that guy's done. Pull out that 9. Remember, it's not the idea of pulling out a common factor. You want to get rid of the coefficient on the x squared. And then remember, you want to leave some space. And now I got to complete the square. Make sure you add the same thing to both sides. That's a subtraction sign. That's a blank. Half of 2 squared is 1, but I'm really adding 9. That factors. And do a little division, and we are going to have it in standard form. Okay, and I have to find the center, the foci, and I have to sketch the graph. So I've got it in standard form now. I can see that my center is going to end up being at -1, 0. So I'm going to go on my graph to -1, 0, and there's my center. And I know I need to move 2 units in the x direction. That will be a vertex. And 2 units in the y direction. That will be another vertex. I need to move 3 units up. And I need to move 3 units down. I can get my box. And I could get my asymptotes sketched in here. And we will kind of graph that hyperbola in like so. So I've got my sketch. Now I need to find my foci. And so I need to remember that c squared is equal to a squared plus b squared. And I have my a squared. And I have my b squared. Make sure you don't square them again. And that means c is going to end up equaling the square root of 13. And we could get a decimal approximation for that, but truthfully, I'm just going to leave it in that form right now. But we can get a decimal approximation. We know that it's bigger than 3 and smaller than 4. But I'll just give the exact value for the foci. So here is the center, and I know that's how many units I need to move from the center, and that center is at -1, 0. So I need to move square root of 13 to the right of center, and I need to move square root of 13 to the left of center. So I will have foci, and I'm going to stick that up here, at -1, and I will add on square root of 13, and that will give me this point over here, which will be moving over about 1, 2, 3, a little more between 3 and 4. So the one focal point will be located about there. And then I will also need to move to the left from that. So I'll move 1, 2, 3, between 3 and 4 units, and I'll have another focal point here. But those are the exact values. Feel free to get a decimal approximation. I just don't have my calculator out, so I'm just going to give it as the exact value right now. Okay, and then one last question, last one in the notes. Yay! And what do you think this is? I've got the x squared and the y squared. Got an x term and a y term. Looks like a circle to me. And I see I'm going to have to complete the square twice. Going to get my x terms together. I'm going to leave some space there. Put the y squared down. And I've got a 4y here. And leave some space and put it equals 8. So I'm going to double check. Got my x squared. Have my y squared. I have the negative 12x. And I have the 4y. And equals 8. And now I'm ready to complete the square. Half of that 6 squared is 36. Add it to both sides. And then half of this squared is 2, plus squared is 4. And now I have a perfect square. And that looks like 48 to me. And I have to identify it, and sketch the graph. Well, I know my center is going to be at 6 and negative 2. And 6 and negative 2. 1, 2, 3, 4, 5, 6. Let's see what this radius is. I might not be able to scale this by 1, so we'll just double check here. 6 and negative 2, we know that the radius is going to be the square root of 48, which is going to be a little bit less than 7. The exact value of that radius, we know that this is 16 times 3, so it's technically 4 times the square root of 3. But once again, that's going to be kind of hard to graph that way. It's just going to be a slight bit smaller than 7. And if I put this way over here and go by ones and down here and put that as a center, I'm going to have a heck of a time trying to graph that on this. So I'm going to have this scaled by 2's. So this is going to be 2, 4, 6, and I'll have this be down here at negative 2. So these are scaled by 2's. 2, 4, 6, 8, 10. I'll just put that 10 up there. Negative 2, negative 4, negative 6, negative 8, negative 10. And I have to be careful when I do this. So this is at 2, 4, 6, and negative 2. So there's my center. And I'm going to move about 7 units out. So 2, 4, 6, little shy of 7. So there's a point. 2, 4, 6, little shy of 7. 2, 4, 6, little shy of 7. And then 2, 4, 6, little shy of 7. And then I could draw my circle. Okay. And you're ready to practice.